So before we jump straight into answering this question, I'm going to first explain the formula that you may have seen for arithmetic sequences and how we can generalize that and then use that formula to answer these questions. So if you've looked at arithmetic sequences already, you may have come across this formula, which basically says that to find the nth term of an arithmetic sequence, we have a plus, in brackets, we have n minus 1 multiplied by d. Okay? And what each of these things stand for. So this is the nth term. So if you're like, this can mean a number of things. As in this question, if you're just wanting to find the nth term as a generalization, we can use that. Or if we're wanting to find a specific term, if you're wanting to find what the third term is or the fourth term is, we would substitute the number 3 or the number 4, and that would go into this area here as well. Okay, so this is basically the number of the term, like the place of the term. Okay, so which term it is, which term in the sequence, which term in the sequence. This A stands for the first term. Okay, first term. And our D stands for the common difference. So you may have come across this formula, and the reason this works is it's pretty simple. It's an arithmetic sequence. Let's say we have this sequence 5, 7, 9, 11, 13, and so on. Okay, we can see here that the first term over here is 5. Okay, and the common difference between each of these is obviously 2. Okay, so if you use this formula, if you want to find the generalization of this arithmetic sequence, then the formula to find the nth term is going to be 5, which is the first term, plus n minus 1, and then multiplied by the common difference, which is 2. And then we can simplify this by saying this is 5 plus 2n minus 2, which is equal to 3 plus 2n. Okay? And what this tells us is that whatever term we want to know, it will give us the answer for that. So if you want to find out what T2 is, right? T2 is equal to 3 plus 2 times 2, which is equal to 7. And we can see over here that that is what our second term is. So this basically just gives us a generalization to find out whatever term in the sequence you want to know. We can use that. And then we can rearrange this formula, as you can do with all formulas, to figure out, sometimes you may not know what the first term is. So you can figure that out. Sometimes you may not know what the common difference is. So we can figure that out as well. So now looking at this formula, I'm just going to highlight that one. So let's clear, and we can focus on that. And now we can answer these questions. So looking at question A, it's asking us to find the formula for the nth term of this sequence. Okay, so I'm going to rewrite the sequence here: 26, 35, 44, 53. And really, when you wanted to find the nth term of a sequence, we really only need to know 2 things. Yeah, we need to know what our first term is, and we need to know what our common difference is. Now the first term is simple, that's just 26. And the common difference, you can just subtract any of these terms, and it's always going to give you 9. So the common difference is 9. And now we can substitute these values into our formula here. And that means that the nth term of this sequence is going to be 26 plus bracket n minus 1, and then the common difference is 9. Now again, expanding the brackets and simplifying, that gives us 26 plus 9n minus 9, which is 9n. 26 minus 9 is 17. So 9n plus 17, that will give us a formula to find the nth term of the sequence. So whatever place you want, whatever term you want, you just sub that into your n, and that will give you that value. Now in B, we're going to do a bit of rearranging, because now it's asking us to find how many terms there are in the sequence. Okay? So, and then we need to find what n is, right? We need to find what n is. And what we do in these situations is we use this last value as our as our Tn, because the last value is going to be how many terms there are, right? If there's, for example, in this sequence, let's say it ends at 13, then T5 is going to equal to 13, right? So in this case, Tn is going to equal to 917. So we know that the last term is 917. We know that the first term is 26. And we know that the common difference is, again, 9, right? It's the same sequence as the one from 8. The common difference is 9. Now, using our formula again, so we know that Tn is equal to A plus bracket n minus 1d. So if we know our Tn is 917, we know that A is 26, and we know that our d is 9, we can just rearrange this formula now. So we subtract 26 from both sides, which gets us, just going to check that, 917 minus 26 is 891. So 891 is equal to 9 times n minus 1. So divide both sides by 9, so that means n minus 1 is equal to 99. And that means that n is equal to 100, which means that there's 100 terms in this sequence. And we can check that by subbing this back into our formula. And when we sub in T100, we should get this last value here, 970. So if we check that, T100 is equal to 26 plus 100 minus 1 times 9. And if you put that in our calculator, 26 plus 99 times 9, and that is 917.